There we go. So when you're entering code, I'm going to show you some examples of what's broken and then what you're going to see in the output. Because the easy answer is have an instructor look over your shoulder. But since this one was set up to be a TOS class, that creates some problems. There's a couple key things that, especially as you're writing the code, will change. So a couple things I want you guys to note. If I misspell, for instance, and I do the capital pin mode, it's wised up a little bit in this newer version. So there may be a little bit more forgiveness in this, but usually it has to stay title case specific. So it has to be exact capitalization. They've maybe added a couple more to the library to try and make that a little easier on you guys. But generally speaking, you need to make sure that if it's a function or something like that, it will change to orange. This won't happen exactly the same way in Tinkercad, but for good discipline, I'm going to make sure you guys are typing in case you end up having to work with an older version of the software or something. You need to build good habits. So we're going to go ahead and do it this way. You open any kind of a function like this because this is a pin mode function. There's a couple things you can do. One of them is you can right click and go to definition if you don't know what it is or how it's supposed to work. And this will pop up this will usually pop up the help window. It looks like yeah, it looks like we're not able to pull that up directly from the help from the command. But in the help, there's a couple things. The reference, some of those details, things about the actual coding environment and troubleshooting. So they have a very large troubleshooting guide. And this is designed to help you guys. And there's a whole section right here called errors in the console. So this is going to make it a little clearer what's going on. So if we go over here to, if we open from the Arduino IDE or from the Arduino site, we can go to their help center. I think you can always get there from the bottom. Yeah, help center. You can always get there from the bottom border. I think it's in the top menus as well. But anyway, what you're looking to do here is you're looking to see what if your sketch doesn't compile, or what if there's an error. So errors uploading a sketch mean loading it onto the board. You're going to be looking mostly in this class, what if it doesn't compile? So some things you can do in the Arduino IDE side is if we set up and we try and do here a let me copy over one segment of this, and then I'll switch windows again so that we can actually see how this works. It'll be easier to see with a live example. It's also going to try to help you in a couple instances. So I'm going to have just a very simple example where you've got the right stuff, but you have wrong spellings, some syntax issues, etc. And that's where we're going to use this verify. So we're going to switch back to the IDE. There we go. So some real simple example code here. Things that I want you guys to be able to see what's going on. There's a check mark in the Arduino IDE, and this is why we're going to do most of our coding in the IDE. And the reason why we do that is the development environments are actually there to help you highlight what's wrong or what's going on. So if we do verify, it's going to say, wait a minute, there's errors. Okay, so in this, what we're looking to see is first thing it's looking for is a fully qualified board name. So it needs to know what board are you using. So we're going to select another board and port. No, I probably don't want to write to my mic or something exciting like that. That would make things very difficult. We're going to show how to add on the Arduino that we're working with. So we have to add the Circuit Playground Express, or at least we used to in this. So if you guys don't have this as an option, we can walk through how to get those set up. The Circuit Playground Express are two different things. So Circuit Playground Express is what we'll be doing most of the time. But what we have in Tinkercad to compare is an Arduino Uno. So we're going to select an Arduino Uno for right now. What we can do is, even without having one physically connected, now that we have a board selected, this error is going to go away and we're going to move to the next error. So now it's going to come up with more error messages. And how we work through those is we start from the top and we see what's going on with the actual errors. There'll be a few. So it'll say unsaved sketch, and here it'll tell you error and then what the error was. So in function void setup, we have an error. What is that error? On line 3, starting at position 11, which is right here, Johnny B was not declared in this scope. So if Johnny B was not declared in this scope, what that's telling us is, hey, we need to tell it what this thing is, because it has it can't read our mind. It doesn't understand what that means, right? So this is the point in the semester where you guys start to learn and start to realize that the reason AI is not going to take over and we're not going to have robots taking all the jobs is pretty simple. If you put just a new variable name with no definition or anything into simple code, it has no idea what to do with it. It has no idea what you're asking for. So we need to define this. And so for some of these, you can look at a couple instances. You can find and change all instances. There's a bunch of helpful right-click stuff, but especially in this mode, if you hover, what it's going to do is give you some more information on what it's trying to do. So it's trying to specify a variable name called Johnny B. That variable name is going to be a type of integer, and we're going to set that integer equal to, we're going to say equal to, we're going to set it equal to 1 initially. So there's a couple more errors this is going to create, but I'm going to go ahead and verify again so that it changes it. So now we have an error. So at line 1, we have an error expected or before void. So it's expecting a comma or a semicolon because it needs to go to the next line. So that will clear this specific error. So we're going to verify again. That'll clear everything. We'll go back up to the top and figure out, okay, now our next error is in the void setup and output was not declared in this scope. Okay, so output, it doesn't understand what this is. This is back to that issue with capitalization. In order for it to understand, it needs to be output. Okay, so now it recognizes it. So this needs to be output, and we need to close the parentheses in order for the function to work. So it understands that it needs a parameter, it needs a pin number, and then a mode. So pin number and then mode. So this is trying to tell us an example, pin mode, and this is defining the pin inside of the function itself. This is defining the mode inside of the function itself. You can do that. It makes sometimes for compact code, but it's not the discipline that I'm going to try and teach you guys first. So this is passed as a pin number converted to an unsigned integer of 8-bit length, and it recognizes now what this variable is. So none of this context information used to be available in prior versions. This is now much, 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 much more helpful as a development environment. So you guys don't really have a sense of how much easier they've made it on you. But this is the process that you're going to go through for troubleshooting all of these things, so that you have a reference point in order to understand what the errors are and why they're coming up. So we're going to look at, we're going to make sure that we have all of these variables defined, and we're going to see what the error looks like now. So it's going to tell you kind of a summary at the top. So again, we're going to go all the way to the right side. So it's expecting in void setup that semicolon before the curly brace. So this open close curly brace, and in the IDE, it'll highlight which curly brace or which parentheses are the open and close pair. And you always need an open and close pair, like 2 pieces of bread for a sandwich. If you don't have 2 pieces of bread, let me know in the chat what happens to your sandwich. If you try and hold on to one side without bread on the other side, where's all your stuff end up? On the floor. So no, I don't actually have office hours to meet in person. There are other instructors who do have some office hours. I am not privy to what instructors have them and when they are at this point in time, but there are other instructors that should be able to help you, especially ones that have taught the ESG math classes, so the intro to engineering math classes. All of those instructors should be able to help. So you might want to look up some of their office hours when you go through the engineering section. But these tools are how we actually troubleshoot them. So this one, we learn that we need to have a semicolon. So we verify again. We've got another error. Okay. So now it's in void loop, and high was not defined because it doesn't know what that is. So if we hover here over high, doesn't actually know what that is. Johnny B, it recognizes what that is, but this it's trying to treat as a variable because it has to be all caps to be treated as a state. So it knows what high is because high is already defined. So spelling and capitalization become really, really, really important. So now those are corrected. We check again. In this case, I'm going to switch this one to low. And we're going to verify again. So now, one last time, we still have an error in the loop. It's still expecting a semicolon before the next digital write on line 11. Okay, so we know we need to close those with the semicolons. So now when we verify, it'll compile the sketch and it looks like this. So it'll say, here's how much memory this is going to use. This is what it's going to look like. The sketch has this many bytes, and then everything will clear. The color also changes when there's known and defined functions, things of that nature. There's a bunch of different functions, and we're going to get into what those are and how those work later. But some of the things that you guys want to be keeping in mind is using this development environment and looking at what the actual error is trying to tell you and learning to understand what those words mean. That's what's going to make the difference between you being successful and you really struggling with this class. So that's the thing to be really paying attention to. And there's a very, very, very large volume of videos out there teaching you tips and techniques for how to troubleshoot these. I'm going to be able to teach you guys a lot of stuff, but at the end of the day, it's going to be up to you guys to put it into practice and reach mastery with the material. So every sketch is going to need sort of three fundamental components. You need your starting point, which is defining all of your variables. You need your setup. So this is code that runs one time. So you define inputs and outputs, and then you do the loop, which is the code that runs multiple times. So we could hit upload on this, but because I don't physically have a board connected, that won't actually do anything. So this, especially if we were to add it in, we could take this, copy and paste it into our Arduino in Tinkercad. So let's go back over to this one. And I'm going to copy that code to get it out of our way. And then I'll share what this looks like, just to verify that this does indeed do something on a real Arduino board like the ones that you guys use. The Arduino Uno is the one that I chose for the engineering math lab, and that's why that one should be familiar to you guys. So let me go back to this one. There we go. So I'm going to copy over our Johnny B. So this code is still going to function in this environment, and we're going to take a look a little more closely at what that looks like. This is going to go relatively quickly, so we're probably not going to see much. It's either going to look like it's on or off all the time. And remember, the way that this was set up originally. Pin 0 right now is set to a high state. So if we wanted to undo that in this circumstance, we could set, if we wanted to turn that pin off, we would do another pin mode definition. This is why we're not going to do a lot of the actual coding development in Tinkercad, is this stuff doesn't change color. It doesn't automatically suggest open and close parentheses. It doesn't tell you which curly brace goes to which one, which parentheses goes to which one. There's none of those sort of little context helps that now exist and are hugely improved in the Arduino IDE. So there's a reason why we use a development environment to write code, because it's actually there trying to help us out. So we don't need to do another definition for a variable name. We can just tell it pin mode pin 0 to output, and we can write in this code that runs one time. We can do a digital write. Digital write, and we can do 0 to low. And this, again, we want to be in the habit of commenting things. So sets pin 0 to off. Here it is sets pin 0 to output. So we know what we're doing. We want to have comments, again, as part of our good habits. You can use the tab key to try and keep even separation for comments. Sometimes that's a lot nicer for actually going through and reading the code. Also, one of the things that we might do as a class exercise is have you guys write a piece of code and then exchange it with a friend and then troubleshoot somebody else's code. That's always exciting, because then you get to see where you really need some comments in order to understand what was going on. So unless you have a photographic memory, which very few people do to the degree necessary, you're going to need to do a lot of commenting in your code. This sets up the variable Johnny B as an integer. So we want to keep track of what we're doing. This runs repeatedly, and what this code is doing is set Johnny B to on and off rapidly. So now, if we start the simulation, we will see that when the code initializes, I'm going to reset it so you guys can see it again. So at start, pin 0 is high because reasons. What this does is, as soon as the code runs, you can't really see it in real time very well, but every time we reset, we can see it. So this shows how many seconds the simulator has been running. If we restart it, you can see that within, this is time in milliseconds. So it takes a couple hundred milliseconds for it to correctly turn pin 0 off, and then leave our pin. This is actually fluctuating on and off. And they have some ways that we can actually see that. The question is going to be, it's under all, and there's an output for an O-scope. There we go. So there's an output for an O-scope, and we're going to do divisions in, we're going to start it at 1 millisecond divisions. We're going to connect this so that the pin that we're interested in, so negative to negative, we're going to keep that black just because it's good practice. Keep things aligned. And this one's going to be red in color just to, again, kind of keep things easy to understand. That was under all components. So what we're going to be doing is we're going to be watching what the startup looks like. So this is basically on all the time. There's no lag time at all. So what we can do is we can add in a delay, and we're going to do just a delay of 10 milliseconds. And for every line we put, we need to add these delay 10 milliseconds. We need to put these semicolons in. So now we're going to hide the code, and we're going to look and see what this does. So if we do divisions of 10 milliseconds, we can see what we're actually doing is we're turning it on and off very quickly, but it's so fast that our eyes can't perceive it. So we'd have to come back in and say 100 milliseconds. And now we can see it flashing on and off. So you guys have no doubt had lots of toys that have been in this general range of super exciting 100 millisecond seizure-inducing madness. But what this is doing is telling us what's actually happening. So the code is what we're seeing work on this O-scope. And so when we look at this, we're actually seeing the on-off, 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 on-off on the O-scope. So we're seeing the on-off, on-off, on-off. This is going up. This is a 10-volt span. So this is going up by, so each of these is 5. So this is going up by a total swing of 1 volt here. And that's about what we would expect, give or take, based on the resistance that we're using. If we change the resistor, we would change what that looks like. But the key is we have a very specific function going on here. So we can zoom back out, bring this back into focus, and we can see what it's doing there. All right, so that's some of how we can alter a little bit about what the code is doing, what the character of the code is. This is part of what we have to figure out in order to make this work the way that it's supposed to. Okay, so questions on this? Is this making sense? Give me another 1 to 10. 10 means I have perfect clairvoyance. I'm at the scale of holy water in terms of clarity. 1 is like dry dirt, no water at all. And then somewhere around like 3 is like original Gatorade flavors, like you can't see all the way through it. Where are you guys at on the clarity scale? This is the quickest way I've come up with to assess. Um, yeah, it's very common. Like I said, the thing that's the most frustrating about anything is when you're doing coding, somebody that knows what they're doing makes it look super easy on the board. Then you go to do it later and you swear you're doing exactly the same thing using exactly the same words, only you have a misspelling error or you missed a parentheses or you forgot something supposed to be capitalized somewhere. There's all this stuff that goes on. Orange Gatorade, fair. Okay, that's why we're trying to go through examples and trying to get everybody to a level playing field with all of this, because that's what's hard. So some of the folks that have done a lot more of this part, they're like, yeah, like I get it already. It's okay. Well, that's for the folks that don't have the depth of experience for this, because I have to get everybody to the same level. All right. So this is why we're trying to walk through some of the code that we're doing slowly, but actually have you guys follow along and do the things. So again, I want you guys to spend a little bit of time kind of trying to put this into practice and seeing if you can do a simple variable definition like this and get the pin modes correct so that you can run one LED only and blink that one. So it doesn't have to be pin 1, it can be pin 2, it can be, you can rewire it to be pin 6, whatever you want to do with it. I just want you guys to put this into practice so that you're not just seeing me do it and go, oh yeah, that makes sense. Try and do it later and then you're completely lost. So let me go ahead and get a couple breakout rooms set up so that you guys can work on it.
Could you show us how to use the O-scope again?
Yeah, the O-scope is super duper helpful, and again, a thing that helps rather than just be purely code. The O-scope, so that's under all components, and you can just do a search. If you type in OSC, it'll come up with oscilloscope. You'll drag and drop that into place, and then you'll connect the wires. That part's pretty straightforward. You click, and then it shows you this super duper glowy thing. You click another spot to make a corner. You click another spot, and you can make all sorts of funny shapes with it. The point is, and when you hit escape, it'll drop out. So that'll be one of the next tricks. So I'm going to go ahead and open up. You'll want both wires connected, and then that should be workable. So I'll go ahead and I'm going to do a little bit bigger rooms, and hopefully that works out a little better. Yeah, let me do it that way. So I'm going to go ahead and open those now. So go ahead and get a start. The last step on that is to just click the device itself and then change the time scale to be proportional to the number that you're putting into the parentheses for that function. All right. And then I'll jump back and forth into the different rooms and answer questions.
Yeah, Professor.
Yeah.
I still don't have my laptop with me, so I don't really have like much of like the stuff down. So I don't
Okay.
really know what to do right now.
I would still go ahead and jump into the room and see what others are doing and engage and ask questions,
Okay.
things like that. So that way you're at least following along with what's going on and where people are getting stuck.
Okay. Sounds good. Can you back into me? Can you put me back into the breakout room? Yeah, it's nice.
Yeah, you should still be able to join at the bottom. So there'll be a control down at the bottom where you can jump into the room.
No, I can't see it.
Yeah, so you're still assigned, but I don't think I can push you to that room. There should be, and you may have to like rotate the screen or something like that in order to
Yeah.
get that control to show up. They may have it at like the top left or something like that too. I don't remember on the mobile screen.
Can I just leave it and come back in?
Yeah, you can do that, and I'll let you back in, and then drop you back into room 2. Yeah.
Awesome. Thank you.
All right. Why did you do that, dumb software? Okay. Strange. All right. Okay. All right. We've got a bunch of you back now. Almost everybody. Still got a few. Okay. Okay. Yeah, we lost a lot on that exercise. Okay. It'll make you like rejoin and do some weird things when you come out of the room. That's apparently the norm. It didn't used to be that way. It used to be a little bit different where you'd just jump back to the main room, but it's making you rejoin the call, which is interesting. So, okay. So we covered a few kind of important pieces there. One of the things that I wanted to cover was there were some more questions trying to clarify for the assignments. We're going to be turning those in with a copy and paste of your code into a Word doc and then screenshots of whatever the output looks like. In this case, it's going to be the output is going to be something like the traffic lights for the first one. The bootloader assignment I've kicked out to next Sunday to try and give you guys another week to be able to get a hold of the actual hardware. If you guys haven't already ordered it, or if you had an order canceled or whatever ridiculous thing, there are other sources that you can use to be able to get those. So there's nothing terribly crazy there. I think the simplest way to think about it is I want to be able to see that you have code that is plausible and workable, and I want to be able to see that you have some options for output working. So if you have code that's has tons of errors in it, and then you show the output as fully working, obviously that's going to be a red flag. I'm not trying to grade you on like the syntax of the code that you're writing, but what I am trying to do is make sure I wanted to make sure that there was an opportunity for you guys to be able to do the do the assignments, get everything turned in, and have it be clear that you're understanding, like, here's what variables are and things like that. So this first part will be pretty straightforward. We're going to start getting into some more specific commands with the Playground Express. So I'm going to see if I can pull up real quick some examples of what that can do and why it is that we chose that as your textbook. The reason we're using this, I had kind of mentioned before, but let me see. So for those that jumped in late and had connection issues and all the other stuff, here is another retailer, DigiKey, that's also a certified vendor for GCU in the purchasing system. the whole Circuit Playground Express operation is actually pretty cool. It has a lot of interesting capabilities, and instead of you guys having to do many things all at the same time, let's do this. Let me see if I can find it. This should play reasonably for you. So there's a couple things. Yeah, let's see. So here is kind of a reasonable overview by a totally credible individual. Let me share it with you. Headphone users, beware, because they don't give me quite the same level. But you should have sound that works.
Steven here from Core Electronics. I'm here today to talk to you about the Adafruit Circuit Playground Express. It's a new board from Adafruit. It's an upgrade on the Circuit Playground, and it's a feature-packed board. It's great for educators, and I'm excited to show it to you, so let's take a look. So the board itself is a circular form factor, which is great for a variety of projects. It's good for if you want to use it as a wearable, if you want to sew it onto something. And the pins on the outside are all alligator clip friendly, so it means that you don't need to solder in order to interface the Circuit Playground Express with other sensors. You could just use alligator clips, and when you're done, you could take them off and the board's ready to be used for another project. The pins on the outside, 7 of them are capacitive touch capable, so they are able to detect if you touch them with your hand or if you touch a wire that's connected to them. On the board as well, we have a micro USB port, and that's what we use to load code onto the board and to communicate with the computer. We have an on light that's on whenever it's powered, so you know that the power is working. And we have a digital communication red light that's on when it's communicating with the computer. We also have 10 NeoPixel RGB LEDs, and these are capable of making any color, and they're addressable, so you can make any light that you want turn on any color that you want. We have a temperature sensor. We have a sound sensor, which is like a simple microphone. We have a speaker. There's a light sensor. There's 2 megabytes of flash memory. It has a ARM Cortex M0 processor, and that runs at 48 megahertz, so it's a pretty fast processor. We have a infrared transmitter and receiver, so that means that you can make a project where the Circuit Playground Express works as, let's say, a TV remote, or it's also capable of communicating with other Circuit Playground Expresses over infrared, or it could be used as a proximity sensor over top of the board itself. There's some buttons on the board. There's a momentary press button A and B, and there's a slide switch that could be selected left or right, and those are ready to be utilized in your code on the board. We also have an accelerometer, so that detects any movement that the board's undergoing. So whether it's being leaned or turned upside down or shaken or free falling, those are things that you'd be able to detect with an accelerometer. So there's a lot of sensors on the board. There's a lot of options for projects that you could do just with the board alone. Now, the Circuit Playground Express is capable of being programmed 3 different ways. The first is Arduino, the second is MakeCode, and the third is CircuitPython, and I'll elaborate on those a little bit. Most makers will already be familiar with Arduino, which is a great language to use if you want to leverage the incredible amount of content that's already available out there. There's so many libraries made, and there's such a force of people already out there programming in it that most problems that you might run into programming, there's somebody out there who knows a solution, and that's great. And you can really get down into some high processes of the board with Arduino. Now, for an educator, though, what I really recommend, and what the thing that I'm really excited about with this board is MakeCode, which MakeCode is a drag and drop interface. It's great for someone who may not have coded before, or just learning the basics of coding and getting their head around the concepts, but it's still capable enough to really make some complex programs. So I'll just plug in this board. I loaded a program on MakeCode earlier, and I'll let you guys see it. So it's a pretty basic program where when you press one button, the lights on that side light up, and you press a button, the other lights light up. And when you give it a shake, they light up in a rainbow. So this is a program that takes about 5 minutes in MakeCode to make. So one of the best things about MakeCode is it's all web browser based. So you don't need to install any software in order to run it. You can run it on a tablet. You could run it off your phone if you like. This is the MakeCode homepage. We'll go to Circuit Playground Express. And in here, there's already a lot of available tutorials for projects you can make with the Circuit Playground Express, and it breaks it down step by step what you need to do in order to make whatever it is that the tutorial is about. So we'll go into my example code. As you can see, on the right-hand side is our workspace. There's a menu in the middle where we select our operations, and then there's a virtual Circuit Playground Express on the left with working buttons on it. So you can basically test your code entirely within the browser without ever connecting your Circuit Playground Express to a computer or loading the code onto it. And then once you see that it's all working in the computer, you can load it onto your board for your project. So just a quick rundown of how this code works. We've got on the left here a forever loop bracket, and this is the button press operation part of the program. We have a forever loop bracket with while conditions inside. So the program will run through this forever loop continuously waiting for a button press. And while the button's pressed, the red lights will turn on, and you can change the color of the lights if you want just with this color wheel interface. So now they all light up pink, and then a clear to turn them off when the button's not pressed anymore. And on the right over here, we have another loop that's continuously waiting for the board to be shaken, and then it will show the rainbow animation for 2 seconds and then turn off. And all this is just drag and drop. It's really easy. Only pieces that fit in the code will work in the blocks, so you can't make mistakes in the code while you're dragging the blocks around. Another cool feature of it is that the actual language that you're programming in with these blocks is JavaScript. So you can click over to see what you've done in JavaScript, which I think is a great educational tool to be able to see at the very least the programming language that you're making with the visual interface. And you could type in here to write your code as well, rather than use the blocks if that's what you wanted to do. The third way to program the Circuit Playground Express is in CircuitPython. So this is an example of the CircuitPython IDE, which is where you program CircuitPython to put on your Circuit Playground Express. So this particular example program is making the 10 LEDs on the Circuit Playground Express light up, then flash, then show a rainbow, then do the rainbow cycle effect that's the same as when we shake the board. So as you can see, writing in CircuitPython is much more involved than the drag and drop make code interface, but it's more versatile. You're capable of doing more things within CircuitPython, and even though it may look a little intimidating at first, it is a pretty good language to use. So that wraps up my explanation of the Adafruit Circuit Playground Express.
Patreon links below, I'm sure, all the regular things. So that gives you guys at least a point of reference for how these actually work. But they're really, really interesting in the range and scope of things that those do. They are very capable little boards, and there's a reason because of all of those different sensors and things that are on them already. He missed several things to point out there that we'll use this semester. So one of them being like a temperature sensor. There's also one so you can figure out like, is your thermostat actually lying to you, and is it actually 74 degrees in the room or is it not, right? So you can actually use this board to figure out whether or not your dorm thermostats are lying to you, because who knows, maybe they are, right? It's warm enough in Phoenix that every degree matters, am I right? So there's that. 74 versus 78, it's a big deal, right? So if you're not getting the 74, then you guys can form a coalition and complain and probably not get anything changed, but at least you'll have data, right? So there's that. Also, you will have learned something. Yeah, so there's that. Next thing that you want to do is you want to get into the details of, so once you get the Playground Express, we're going to get into some of the examples there. So you noted he cited 3 different methods of doing the programming. We're not going to be using the code blocks method because it's fairly limited in terms of what we want to be able to do. So there are some examples, like one of the semesters we did a voting machine where you could press one button for one side and one button for the other side. And so it would do the obvious thing that voting machines do and take whatever input you put in and select the quote correct candidate. And so I'll let that sit where it lies, but we showed how simple it was for the code to do that. So while on the one hand, it's very simple to have the code do what you think it does, it's also very simple for the code to look right to a layman and actually to have a provision to do funny business with variables and all sorts of things through iterations and loops and all sorts of things that are very subtle. So a lot of interesting things that you can do with those. But that requires having it plugged in through USB so that then you can get, so you may have to make sure that you've got the right sort of USB cable to connect to it. Most of the Playground Express kits are kits with the USB cable. If not, you might have to get a USB cable for it. So you'll have to just be mindful of that. If you happen to get one and it's board only and they advertise it as a kit, like it's not a big deal. Just make sure you get the right USB cable and you'll be good to go there. So they're very, very capable little boards. There's also a thing that you guys will appreciate. Another one that we do during the semester is, at least I'll check and make sure it's still in the syllabus. we had a really interesting one where we respond to we responded to the level of sound, like someone playing music, and might be one of the demonstrations, almost certainly one of the demonstrations that we'll do. They can also record data, all sorts of things like that. So there's a lot of really, really interesting stuff. And we'll show you how to control the LEDs and make them do stuff. He also mentioned a category called wearables. How many of you are familiar with what that actually means? Anybody? Nobody knows what wearables is?
Where you wear a circuit board on you.
So that's a good guess. Wearables are a little bit more extreme. Let me see if I can find an example.
Prosthetics or something?
Almost. Let's see. Trying to see if I can find an example.
Stuff that goes in your body, like a pacemaker?
So it's here's an example that we'll share as soon as the audio is done for the ad. Almost there. Okay, here we go. So this is similar content to what's often like 300 level classes for other universities, but at least give you a concept, because all these people that were bored during COVID, that thing where people said horrible, awful things to each other.
My name is David
Had a
Pierce,
lot of time.
and for my Shoulders of Giants project, I decided to make these music gloves, which each utilize an Adafruit Circuit Playground Express, which is just a small board with about 20 different sensors or so. And for this assignment, I used the accelerometer, the LEDs, and the speaker to make music based on how I move my hands. The separate speaker module that you can see is a plug-and-play type speaker that amplifies a smaller speaker on the board directly without the need for a specific code. And so, let's see how they sound. Alright, so these are the gloves. You can see each stem speaker wrapped around and on my wrist, going to and from the board, as well as the battery pack, which is under my wrist. And so I'll turn them on. And then when I tilt my hand up, you can see the tempo goes up. And then when I tilt it down for a second, it also goes up. And then when I get a little shake, they'll start. And yeah, they only play for 10 seconds, so I can bring the tempo down again. And then I'll shake again. There we go. I used a tutorial for these gloves on Adafruit's website and adjusted the code within Microsoft's MakeCode program specifically for the Playground Express. The program has both JavaScript and block code programming, as well as a virtual board that I can use to test before applying it to the real one. In the code, I have it so the Playground Express repeats this tune 10 times, and based on the rotation axis of the accelerometer, it changes the pitch in real time as my hand moves. When I tilt my hand up, the yellow lights flash, and the tempo is sped up by 30 beats per minute. And when I tilt my hand down, the blue lights flash, and the tempo is decreased by 30 beats per minute. Unfortunately, I wasn't able to make the glove more compact and clean because of some soldering issues, but at least I was able to make do with what I had. And I'll leave you with the sounds of those soldering issues. Might be a little loud. Thank you. All right. I thought I did a good job with the soldering, but as you can hear, it doesn't work out very well. All right, that's enough.
Yeah. So another example of how things don't always go according to plan. But the idea is there's a whole field of wearables. So should one of you be some sort of a nerd, just hypothetically speaking, there's a lot of cool stuff that you can do with these kinds of circuits in order to make stuff cooperate. So there's a lot of interesting options for how to build a lot of these components, how to do a lot of different sorts of projects. There's a lot of ways that you can operate these components and do all sorts of little features like lighting things up.
Bro's Iron Man.
So, that was one of the masks that I wore during COVID because during the height of a term I could never unhear COVIDiocy, I was one of the few that understood that you can't put underwear on your face and stop a virus. Simple math, but a lot of people were super confused by that, especially scientists like Bill Nye. But anyway, since math is hard, so I want you guys to be able to do math correctly when you go to do programming. So these are cool little circuit boards that have a lot of expandability beyond just what you're doing in class, which is why I'm trying to teach you how to think about the programming and how to think about the code, not just here's what you do to write this exact code, because copy and paste of code from Google is not really going to get you mastery of anything, right? All right. Questions on the assignments so far? That is fair. I've also not seen Tony Stark and myself in the same room at the same time. So there's that. And the thing that looks like what could be a football up behind me is definitely 100% not a football. Bonus points if you guys ever figure out what it actually is, but that'll be a game for another day. Any major questions on the code or anything about this right now? Well, that'd be the probably the world's single worst basketball ever. I think it weighs about 18 million pounds, and bounce it will not. All right, so that'll leave a mystery for you guys to solve throughout the semester. Yeah, go ahead with your question. Okay, no questions there. Good. Okay. So what we're trying to do with this semester broadly, you guys have seen another couple examples. One of them is another coding environment where it uses coding blocks. Another one was a coding environment where it does the same code but in Java in the background, which is why it runs on the web browser and you can download the code to the board from that. There's a lot of different ways to program things, a lot of different base languages to use. However, we want to make sure that you guys are getting a grasp on how it is that you make those work and operate, and what some of those are. So there's a couple reports that you guys are going to be doing and turning in this weekend on a couple different varieties of coding languages. And we want you to focus in on some specifics. So those are outlined in the actual assignments themselves. Those are things that you can look up. There's lots and lots and lots of information on. We want you to just highlight some of the differences between those so that you get a sense of coding in general and what is actually involved. So, all right, that was the main things that I wanted to cover for today and get you guys through some more examples and actually practically using variables. Any other question about the class itself or about class mechanics, etc.?
So on the compare and contrast assignment, we're just like doing research to find like the pros and cons of each scripting language.
Yeah, it's trying to get you guys to see that there are differences, one, and that two, there's really not so much like a right and wrong, like they're just like the flat brim vaping kitties that drive the Subarus. Like there's groups of people that do the groupie things, right, everywhere. You guys all know probably at least one guy that fits in that category. They will all say that their group is best group because whatever, right? Just how it is. The coding languages are about the same. Everybody will tell you, oh no, Python is best because, right? It's the same thing. Like if you go to Cars and Coffee, some dude's got a vet, like my Corvette's best Corvette because it's same exact thing. Some are easier to use for some people than others, and that's the actual truth behind it all. So we want to teach you guys in really one core language. Primarily, Arduino and MATLAB are similar at many levels, but they do different things very well compared to each other. So there's some kind of hit and miss there that we need to pay attention to, but it's very different programming languages do different kinds of tasks very efficiently, where they do other tasks very inefficiently compared to some other language. So there is always a cost trade. And for some of them, the learning curve can be a little bit steeper if there's not as many resources available. Some of them, like Python, are trying to be a little more accessible to people who haven't coded before. Code blocks type coding mechanisms are the same thing. There's also like visual coding mechanisms. Some of the software that I've dealt with is visual, where you set up blocks and then you connect inputs and outputs as like wires in the drawing, like Tinkercad, and that is a whole other separate thing. But even in Tinkercad, I'll show you guys an example that they have for the code. So I'm going to copy all of this before it deletes it. But it'll show you sometimes blocks as well, or it'll give you the option to look at it in terms of blocks. So same kind of idea, same kind of forever loop. So it's the same block type coding language, and it gives you some access to some built-in things. But there's a lot more to these, and it might be helpful to reference this in terms of looking at, okay, I want you to read something, I want you to do something, right? So there's a lot of different things that these can do. And we'll learn about loops and control, if statements, conditional, comparator code that we're going to write. There's all sorts of things. So, and then comment blocks for notation, stuff like that. So there's a lot of these that can be kind of helpful, but very quickly this is going to feel constricting to you guys compared to the disciplines that we're going to be teaching you by going over purely to text mode, because this is a very C++ kind of code. And that's part of what it's trying to do, is be able to show you some of the different examples of how code is put together, because very soon we're going to be doing a lot of different kinds of things within the code. We're going to be having to control individual lights to do different things, individual sensors we're going to read, then we're going to output stuff to the serial monitor. And when you start using blocks for those kinds of many hundreds of lines of code equivalent, it's just not, it's not as clear. So like blocks are great for simple concepts and simple execution, not so great for a multivariate comparator arrangement or something like that. So, all right. Other questions? Or are you guys feeling a little bit more confident? Feeling? Give me a final 1 to 10 on how scared you are now about coding. 10 being like, oh my gosh, I'm losing my mind, and 1 being like, all right, I got this. No big deal. So anywhere around like a 6 or a 5 average, looks like we're about there, is actually doing pretty good.
Did you say you moved the understanding your Arduino or essay till next Sunday, or that one's this Sunday still?
That one is this Sunday still. It's the one that's updating the bootloader on your board. That is the one I moved to next Sunday to give you guys another week to actually get the hardware in. So we're still going to be continuing to build fundamental concepts and start learning more about how to correctly structure code and things like that. But I wanted to give you guys a little more time to actually physically get the hardware in your hands. And I also know that like 2.5 hours twice a week is how to turn you guys into like bowls of over microwaved oatmeal. So there's that. So I'm trying to make sure we get to the content, get to the application, get questions, and then usually the last half hour people are just not really fully functional anyway.
Yeah. So we need an Arduino and that little circuit.
No, you don't need both. But if you still have your Arduino Uno kits from the Intro to Math Engineering Math Lab, you can certainly start doing some of the things and kind of mimicking it. The idea is we want to focus more on the coding and less on troubleshooting circuitry in this class. That's why we have a different physical unit, because we kind of argued back and forth a bit about what would be best. I thought it would be good to use one kit that was already, you know, paid for and all of those things, and just deal with the circuit issues in the class. But others expressed great misgivings about those. So yeah,
Fair enough.
circuits scare people that aren't circuit people. It's just a thing.
True.
All right. So if there's no other questions, then you guys are good to go, and we will reconvene next week.
Sounds good. See you.
Have a good day.
Have a good weekend, guys.
Bye.
Oh, I had a question.
Yeah.
So will this assignment be turned into the blinking LED, the one that we did right now? Okay.
Yeah, so the one that you're working on now can go to the blinking LED assignment. That's why I wanted to sort of start there, is get you guys started on a even level footing, and kind of start getting a sense of what is coding, what is all this stuff, what's this coding environment, trying to make sure you guys are getting a grasp on it.
That makes sense. Makes sense. Thank you. Appreciate it.
Absolutely. Have a good one.
You too.
Do you have a minute?
Yeah, I do.
Okay, so can I share my screen with you really quick?
Yeah, you can.
Okay,
I will
so
turn that off.